Welcome everyone. Thank you for joining this session where we are very lucky to be joined by Ollie Preslin from Ensono, who will be sharing how and why automation can be crucial to performance monitoring with real life case studies. Feel free to leave any questions as we go along in the chat box and Ollie will answer them. Also, at the end of the presentation, we would be grateful if you could leave session feedback as well using the link I'm about to paste in the chat box. So with that said, over to you, Ollie.
Super. Thanks very much, Piera. And good morning, everyone. And thanks for joining this first session of the day. I'm, as Piera said, Ollie Preslin. My role in Ensono is in the product and technology organization. So I've spent a number of years working on managed services across all sorts of platforms, from mainframe to public cloud and pretty much everything in between. But my current role is working in our consulting organization. For those who don't know us, we're a large mainframe managed service provider, but we do a lot of more innovative things with the mainframe platform, helping clients modernize it. And I'm going to share some experience today from my last couple of years working with application performance monitoring across really diverse large enterprise environments, showing how using a combination of application performance monitoring and actually automated responses triggered by that application performance monitoring to solve a whole host of business challenges. And how a lot of people use APM at the front end of their applications, thinking about client experience, but actually end-to-end and involving the mainframe in that end-to-end application performance monitoring can deliver some really interesting benefits. I am a mainframer by background. I joined IBM in the 90s, and after a misspent youth of PCs and the internet, they sent me to learn COBOL Kix DB2 on a System 390. I've been involved in mainframe throughout my career, on and off, with large migrations for insurance companies and others, and spend a lot of time talking to CIOs nowadays about how to modernize both on the mainframe platform and integrate with the more modern forms of application development that are typically popping up in the cloud, and make the mainframe a more valuable asset, opening up the data and the applications on a mainframe to those front-end systems, making it really easy for those modern application developers to be able to access the mainframe, and for them to embrace and be able to develop on the mainframe too. So let's dive straight into it. This is kind of the compulsory COVID slide, but actually my point here is not really that, these are new challenges at all. It's just that we have definitely seen, and I personally have seen in client conversations over the last best part of a year, that some of these challenges we've always had with applications, availability, performance, troubleshooting, conflicting priorities in the business have just been heightened. So I'm just going to walk quickly through setting a bit of context for what I'm going to go on to. So in terms of increased online demand and expectations, particularly those public-facing critical applications, the ones that are responsible for either the revenue of a business, the client experience, the things that drive core foundations of the way that customers interact with businesses, demand and expectation, whether you view it through the lens of millennials, the smartphone, whatever, have definitely been increasing in terms of always on availability, incredibly quick response time, consistent experience. And so if I can get the slide to build, in being able to assure that customer experience has a real link to loyalty and stickiness now with those business applications. We've seen a massive acceleration of some of those initiatives to digitally enable businesses this year in response to the pandemic and everybody wishing to access business services via the internet. One of the things that means is a lot of fairly rapidly moving transformation, more rapidly than we've seen in previous years. And as a result, as you go through those modernizations, make changes both to infrastructure and applications, being able to manage the risk, and that might mean getting a really clear view of your baseline before you start the change, being able to manage performance and expectations through that change, and then being able to re-baseline at the end and say, actually, things got better, and here's how, and here are the improvements we made along the way. That's one of the benefits of application performance monitoring. I'll go into some examples of that. And then, of course, with remote working, that external audience availability remains absolutely paramount and critical. One of the things you might not naturally associate with APM is the ability to get involved in the security space. Being able to identify security threats, attacks that might be coming in from a client experience viewpoint, being able to pinpoint those and block them, that's another side benefit. And then, of course, with the changes of priority over the course of the last year, we've seen a new dynamic in how cost is being allocated to projects, whether it's those kind of survival initiatives, the digitization, and spend being diverted away from things like life cycle and other activities. And then, of course, executives are wanting more and more insight from a customer viewpoint and from a business process viewpoint into their applications, their performance, the end user experience of them, and being able to give deep insights, accurate metrics, enable decision making is really, really critical. And I'm going to contrast traditional approaches to monitoring with what's termed application performance monitoring and really show why there's a drastically different and why APM can give us a lot more in managing our applications. So couple of brief market stats, almost mandatory. Everybody knows the cost of downtime is significant. But what's more interesting is a number of surveys have been run, I'm just quoting one here, about organizations and how they feel about whether they have the tools and the metrics to actually accurately and consistently view the end user experience of their services. And it's a pretty low number, with only just half saying they think they have adequate tools and insight on that. And then finally, pretty much everybody agreeing, yes, if I had an improved end user experience, sure, that's going to follow through into my business results. So let's talk briefly about some of the traditional IT challenges with managing applications and infrastructure. So we all know if an application's down, it's a pretty kind of 0 or 1 issue. And what typically happens is a bridge call is spun up. You've got subject matter experts from all parts of the mainframe community, the cloud community, the database, the network, etc. And it turns rapidly into an exercise in mean time to innocence. Essentially, hey, look, my tool's saying everything's green, it's all fine. It must be another part of the end-to-end infrastructure or application. What becomes even more difficult than that kind of 0 or 1 situation is where you're getting end user feedback, and nowadays that could be via Twitter and Facebook quite often, that actually they're getting an inconsistent experience from your massive global public facing web application, for example, or the performance is degraded, and pinpointing those kind of issues where you've almost got a brownout on the service. It's not quite down, but people are experiencing a poor experience in the application, and that, as we know, lots of evidence shows, goes on to affect loyalty with applications. So being able to pinpoint and resolve those issues very, very quickly down to the line of code, the business service that's sitting inside the application, the particular database call that might be underperforming, the part of the network connectivity between a highly distributed application and maybe latency that's occurring at a particular point. And then being able to give that information to the subject matter experts and resolve it is becoming more and more critical to ensure really high availability. Again, there's this constant gap in businesses typically where you have silos of the application teams, the infrastructure teams, the business view, the marketing team, etc., versus the IT view. And a lot of traditional monitoring, it might be all lit up and green for IT, whereas the business is seeing impact on their end user experience. Bridging that gap, being able to have a single view that both parties, the business view, the IT folks, both app and infrastructure, can see, that shows exactly what the real experience and performance of the application looks like, is becoming more and more critical as well. Getting insight, particularly in an agile development environment where code is constantly being changed, released, etc., being able to get insight into those potentially small code changes, they might have large ramifications of the performance of an application downstream through the architecture, and feed that back to the application team to put onto their backlog for prioritization and fixing. Again, a really critical item. As we've seen massive adoption of public cloud for large, scalable, often auto-scaling public-facing applications that access critical systems such as the mainframe, other platforms like IBM I, etc., in the data center, we've seen massive complexity of the number of technologies in use, both infrastructure-wise, types of application coding, databases, etc., and that's increased the challenge on being able to monitor end-to-end. And every time I've been in a client environment and deployed application performance monitoring tools, we've uncovered things that people didn't even know were there. previously unknown issues, as I mentioned, kind of inefficient application coding, database calls, etc. And that's been really insightful. These are things that potentially are increasing capacity that's required to process and manage the application. So there are cost-saving opportunities there, but also they're not necessarily affecting and causing downtime or affecting the end user experience. It's just inefficiencies that IT can make better at the back end. So let's just visualize for a second the level of complexity that a large enterprise might have today. So growing out of the data center over the last 20 years, we've probably got a load of virtual machines where they're running on VMware. We've probably pushed a bunch to the public cloud. As I mentioned, multiple generations of applications, COBOL, Kix, DB2, all the way through Java to .NET, PHP, all sorts of new modern Ruby on Rails, etc. And then as part of that environment, that ecosystem underpinning, as you can see on the right-hand side, at the end of the day, a consumer or customer or business experience, whatever device they're coming from, wherever in the world, always on, expecting availability and high responsiveness, with all sorts of applications, private clouds, mainframe, everything forming part of that end-to-end ecosystem. Most of these teams that manage those different platforms, most of the teams that manage the different applications, most of the teams that have different development environments have their own tools for that purpose today. Bridging it's the critical piece. So there is a new way of addressing monitoring that's radically different from that kind of stack of monitoring tools that you see on the right-hand side, those silos across the different technologies. And it's really to say, instead of looking at components of the technology stacks, be the application or infrastructure, at each part of the end-to-end architecture, and then trying on a bridge call or with some clever in-house scripting and coding, trying to pull that all together to get a single view, actually, isn't there a better way? What if I was tracking the individual users of the applications, their transactions, and I was able to trace them all the way from the initial hit on the front end, the GUI or UI of the application, trace that transaction through the application layers that it goes through, all the way to the database and backend, potentially out to third-party web services and other things my application might integrate with, and be able to see where on that transaction slowdowns are occurring, bottlenecks might be appearing, where's the experience being affected, and is that variable? Is it consistent? Am I seeing a trend over time? Is it just at this point in time I have an issue that I can pinpoint and resolve? But it's a different way of looking at it because you're tracing the actual user journey rather than looking at the technology stack components. Now, if you're able to trace every single business transaction through a system, and when you see something untoward happening based on automation and setting thresholds on response time to the transaction, or individual business triggers around process speeds and those sorts of things, you're able to really pinpoint it down to what's going on. And the other benefit of that is you can actually map that kind of monitoring into your business journey. So if you have and I'm going to show an example later, but if you had, for example, an insurance quote process, a claim process, and maybe a payment of a premium process in the insurance industry, you could actually map up in a customized dashboard a view of your business processes, those three different streams, showing the steps that the consumer goes through as part of the transaction they're trying to perform, and how that relates to the underlying components of the application architecture, and then visualize where is it in terms of your business process that you're seeing impact and what that impact might be. So it's a very different way of looking at monitoring, starting with the consumer experience and then tracing that through the application end-to-end to identify how performance is really affect your business experience. I mentioned as we become more and more highly distributed, complexity of systems, the interdependencies have just grown into an absolute spider's web. So speed to resolution of problems, being able to identify root cause very quickly, get that detailed information down to the line of code, down to the database call, down to the infrastructure component, and pass it to the right team is absolutely critical. It's this conversation, this kind of presentation really is about customer experience and being able to deliver that. So how do we get that level of business and IT insight that's not been available before? And I'm unashamedly using screenshots in this from one particular technology. This isn't at all a sales pitch. This is sharing my experiences, some real world application performance monitoring, troubleshooting, etc. But the technology that you're going to see here is one called AppDynamics from a company called Cisco. They acquired AppDynamics a few years ago, and the integration with IBM. And I'll apologize now, I work with the Americans a lot, so I'm going to say Z rather than Z. IBM ZAPM. Which enables us to bring the mainframe into that end-to-end view in a very, very impactful way. So if I could view my application, and this might look like an infrastructure to you, but this is absolutely an application view. Each of those green circles represents a tier in the architecture of the application. So I might have 4 .NET components all doing the same thing in a load balanced array, but that forms part of the application architecture and would be represented by one circle here. I might have a series of Oracle databases, again, represented in one of these tiers. I might have a third-party service, my front-end website, etc. But if I can visualize my application architecture and on each of the arrows between the components, be able to have a dynamic flow map, as this is called, built up in front of me, showing what volume of transactions are going between the components? What's the latency currently between those components? Get a health view based on thresholds that I set as to what my acceptable experience is. When do I consider it kind of a slightly degraded experience and I want things to start lighting up amber? At what point do I consider actually this is a higher error rate than I expect, a higher response time than I expect, and I want to be seeing that as flagging red, and then being able to automate off the back end, whether it's raising tickets to the right teams to be able to resolve those issues, or actually automating the response through some smart automation, scripting, and other techniques to be able to actually resolve those issues, close the ticket automatically, and then pass it to somebody to do kind of root cause and how do we avoid that in future. Those business health rules that are talked about on the left-hand side are really the modern, in my opinion, way of setting monitoring thresholds. So we're setting thresholds, as I mentioned, against kind of user experience response. We're setting thresholds against error rates that we're seeing on particular components of the architecture, and conversations are going on between components of the application, and then being able to trigger automated response off the back end of them. I talked a little bit about this insurance example. This just gives you a visualization of the kind of dashboard that you can create, and being able to double click and drill through, you can see that there are a couple of components currently passing their thresholds. They're either not responding quickly enough, the error rates have gone up, or there's some sort of latency between components. Being able to double click down as a technologist into that business flow map, and then immediately see, okay, which applications and components does this relate to, what's causing the issue, and bridge that gap between the business and IT views, really, really important in the modern world of monitoring. So how do we integrate the mainframe into this? Because a lot of application performance monitoring tools that are out there are very much focused on kind of the non-mainframe world. And actually, the integration of IBM ZAPM with this particular technology has given us the bridge that enables an end-to-end view. So you can trace transactions all the way from the user's browser or thick client application through the components of your business logic to the back-end critical transactional systems such as the mainframe, the databases, the KICS, some of the older technologies, IMS, and some of the more modern technologies, Java Stacks, DB2, and other things, and web services that might be running on the mainframe. And I've just highlighted the bridge there because you can see this is a single end-to-end dynamic flow map of a real system with a mainframe at the back end and a series of components at the front end on the distributed world. And that bridge is formed across the middle where the transactions are moving between the distributed world and the mainframe there, but we get a single end-to-end view. So how does that work in operations? Well, those thresholds that I talked about, once you have this end-to-end integration system, can be flagging alerts really, really quickly and providing detailed context that the mainframe system operators and others need in order to be able to dive directly to where the cause of the issue is. So in this example, we're able to track some KICS transactions. We can see that the issue is related to a particular KICS region. We've got a task ID. We can provide a URL link to provide APM detail and pass that over to the KICS SME. So the KICS SME will use whatever tool their preferred is, go in and take that information around the region name, the task ID, etc., and immediately deep dive to where the problem is and resolve it at the back end. So it provides context to the mainframe operator in that single tool. In terms of integration of what I call cloud and mainframe, technically, essentially, there is a component that's generally deployed that sits between the mainframe and the distributed world, and you can see that's this transaction tracking gateway, and that's helping to coordinate and keep track of the timing of those transactions that they flow through. The application call that's coming from something on the distributed world, in this case into the Kix engine on the System Z, is following that application transaction all the way through Kix down to the DB2, and we're tracing it back again. So there's technology components using ZAPM on the mainframe. There's this transaction gateway in the middle, and then the single APM controller that's aggregating that end-to-end view, and that's where we go for the visibility, whether we're a business team, a mainframe team, a distributed team, database crew, whoever we are. In terms of the level of integration you can get with mainframe today, you can see there's a real breadth of both older and more modern technologies that run on the mainframe that can integrate into this sort of system. I've got globally around 70 mainframe clients who have the full variety of technologies, the most modern you can imagine and the most ancient you can imagine on the mainframe as well. But they've all got generally public cloud applications that are trying to hunt back to key business data that's sitting on the mainframe. So you do really need this level of coverage to get the full end-to-end picture. Now I'm going to share with you in one of the client examples a gotcha, which is something to look out for. This type of technology, to be able to trace a user transaction all the way through, requires application conversations to be going on, and I'm going to talk about screen scraping and how that causes a bit of an issue for APM. But if you've got application calls being made to API interfaces, to Kix transactions, to MQ, etc., to database calls to DB2, then you can absolutely get an end-to-end view of this. The other thing about APM, because it's so focused on the customer experience, you really want this kind of component, which many might see this as something like Google Analytics, a solution which is very much aimed at the teams who deal with the user experience, the front end, the GUI experience, where's the traffic coming from, etc. But if you've got an APM system that gives you that kind of capability at the front end, the visualization of the application performance, the ability to drill down into the technology view, then you really have the end-to-end that you need, rather than, again, siloed tools. So let's talk about a couple examples, and these are very real world. The three I'm going to share with you are all in the last 6 months. You'll see on one of the slides the date of October. It was an actual example from last month, but I just want to share some ideas and thoughts and some examples of where we've seen this technology coming into play. So this is a very large public sector organization, not in the UK, but they were providing unemployment and other benefits. So critical system during COVID, a lot of people finding themselves in a position where they needed to register for benefits, get quick payments in order to maintain their livelihoods and look after their families. They saw a huge increase. It was actually nearer 400% and 300% in demand. Now, this system is a web-facing, public-facing application. There's a .NET application tier in the middle. And the critical piece that turned out to be the challenge for us was the screen scraping going on between the .NET application and the fairly old application that was running on the mainframe with a 3270 front end to it. So immediately, the bottleneck and the finger was pointed at the mainframe. What we actually found by deploying APM quickly to the .NET application tier was that was actually where the bottleneck was occurring as the load increased to the point at which it did. Now, screen scraping is a gotcha in this, and I really do want to flag it because this became a bit of an issue for us. Screen scraping breaks that end-to-end ability to trace the transaction all the way through, because essentially it's not an application header or ID that you're able to pass all the way to the back. You're literally interfacing and treating the mainframe as a black box. As a result, we were able to monitor at the front end, monitor at the back end separately. But if you want the end to end, it's best suited to applications that are making real transactional calls from middle tiers to back end. So what it did highlight, though, to the CIO was, okay, I haven't got time to fix that application issue and remove screen scraping from the equation, but that's definitely on my 2021 roadmap as a strategic application change. It meant that some tactical fixes were able to be pinpointed, put in place. The finger was pointed away from the mainframe to where the application issue actually was. That was able to be scaled. Some code changes were able to be made, and the resolution was effected pretty quickly on this one. So example number 2, again, I mentioned you wouldn't naturally associate security attack diagnosis and prevention as part of application performance monitoring. So this is an October example. I think the dates may be somewhere on here. Large client, distributed system, public cloud front end, SAP in the data center, big enterprise systems at the back end of it, started seeing a crashing off in user experience, and that was triggered through automation. We got the alerts around the end user experience times. You can see the geographies they normally operate in, mostly Europe. So Germany, United Kingdom, France, Spain. You can see the volumes of requests. Those are typical business day volumes for them. Suddenly, we were seeing the end user experience for those legitimate users crashing off. Immediately going to the tool here, we're able to see that actually Hong Kong is driving 6 times the traffic of Germany, our usual business volume. Being able to pinpoint that and then drill into the traffic and give the IPs that the traffic was coming from to the security folks that they could lock down and just block that traffic very, very quickly, pinpointing and dealing with the issue. To be honest, we weren't expecting APM to give us the pinpointers to exactly where to go on this, but it was the easiest tool to use and be able to deal with that issue. My final example here is where it's a kind of unexpected impact on the mainframe that was seen by another client. Very successful online marketing campaign. It's a retail organization, again, a public-facing website, international market. The public cloud front end is enabled for auto scaling, so it scales dynamically to the user demand. They had an incredibly successful marketing campaign. Hadn't really talked to IT about it, unfortunately, but the marketing campaign came through, massive increase in demand at the front end. The new features, capabilities, offers were put out very quickly onto the website through DevOps, agile application development, continuous integration, multiple code releases shipping every day. But the unexpected demand on the application drove a significant workload at the back end of the mainframe. And what turned out to be the case was the code that had been shipped in the front end had some very, very inefficient database calls. It was calling the back-end database 10 or 12 times when that could have been wrapped up in a single database call to the DB2 on the mainframe. As a result, massive load, increase in MIPS on the back end, and unexpected impact. Now, of course, in the world of cost silos, where the marketing budget is one thing, the folks developing and managing on the public cloud is another thing, and the mainframe cost is at the back end, nobody was really considering the end-to-end impact on capacity requirements and those sorts of considerations. Fortunately, they were able to pinpoint that poor bit of database coding, fix it, and lower the impact on the mainframe. But what this showed was there's a real business case for application performance monitoring and applying these same techniques to development and test environments, not just production. So when that code is shipped, it's pushed into a representative system that can have a load run against it to see where are these bottlenecks going to appear. Can I scale and to what point before I see an impact? Is that going to impact my end-to-end cost? Have I got well-written code, or actually are there optimizations I need to make? Can I get that information back to the development teams very, very quickly? So unexpected impacts and the ability to preempt those through this kind of capability as well. So I've got to the end of the slide deck. Questions were invited as we went. We haven't had any, but I'm very keen to have a dialogue and go through anything you'd like to talk about now on APM, experiences on mainframe, end-to-end, and how some of this technology can help.
Just as a reminder, if anyone wants to ask questions, feel free to type in the chat box or let me know if you want to speak instead, and I can unmute you.
And if there are questions you don't want to ask in the open forum, you can see my email address there. Very happy to give advice as a peer, as kind of real world experience on some of the benefits and how to use this technology. Please do just reach out to me.
Sure, I don't think we're getting any questions right now, but as you say, yeah, if anyone wants to follow up, I think the email is right on the main screen there. So feel free to take note of that, and you can follow up separately. But thank you all for joining. Really appreciate everyone coming on, and of course, Ollie, really appreciate your time as well and presenting it. It was very insightful indeed. And we'd be grateful if you could leave session feedback as well. I've put in the links in the chat box, and also a link to the giving page for our chosen charity, NHS Charities Together. We would highly appreciate any donations as well.
Yeah, really appreciate the feedback and support of the charity. Thanks very much, Piera.
Brilliant. Thank you all. Well, I hope you all have an amazing rest of the day. Thanks, Ollie. Thanks, everyone.